Let's talk about that sinking feeling. You know the one, where your setup works perfectly on your own machine, but the second it hits the cloud, everything just falls apart. Well, today, we are going to solve that. We're going to go from the wild west of manual clicks to the clean, predictable world of code.
I mean, we've all been there, right? You spend hours, maybe days getting everything just right, it's flawless, then you hand it off, push it to a shared environment, and boom, total chaos. Settings are different, things are missing, nothing works. It is honestly one of the biggest headaches in development. And that headache, that frustration, it actually has a name. It's the manual cloud problem. It's what happens when we build our digital worlds by hand, clicking through web pages, setting up one server, one database, one little network rule at a time. It might feel like you're getting stuff done, but really, it's a trap. And this slide, it just lays it all out, plain and simple. On the left, you've got the old way, what we call ClickOps. It's messy, it's inconsistent, and it's just begging for human error. But on the right, you've got the infrastructure as code way. Everything is consistent, repeatable, super fast, and built for automation. It's order versus chaos. So if all that manual clicking is the problem, what's the fix? Well, it's pretty straightforward actually. We need to stop clicking and start coding. It's time we start treating our infrastructure just like we treat our applications, as code. And that brings us to this big idea, infrastructure as code, or IAC. Put simply, it's the practice of managing your entire cloud setup using code files. I love this analogy. Think of it like a digital blueprint for your whole system, a master plan that anyone on your team can use to build the exact same thing every single time.
And the benefits here are just huge. You get consistency, so you can finally say goodbye to those "it works on my machine" problems. You can use Git to version control your entire cloud, so you have a perfect history of every single change. It slots right into automation pipelines, for CI/CD. You can spin up identical environments for dev, staging, and production in minutes, not days. And my personal favorite, the cost savings. Seriously, when you're done with a temporary environment, you just destroy it with one command. No more paying for stuff you're not using. Okay, so the idea is awesome, right? But how do you actually make it happen? You need the right tool for the job. And these days, in the world of IAC, that tool is, without a doubt, Terraform.
So what is it? Well, in a nutshell, Terraform is the engine that takes that digital blueprint of yours and brings it to life. It's an open source tool from HashiCorp, and it has pretty much become the industry standard for a whole bunch of good reasons.
First off, it's multi-cloud. It doesn't matter if you're on Azure, AWS, Google Cloud, whatever. Terraform speaks their language. But the real magic, the absolute game changer, is its declarative syntax. Instead of writing a long list of step-by-step commands, you just describe what you want. You describe the final destination. It's kind of like ordering a pizza. You tell them you want pepperoni and mushrooms, you don't give them the recipe for the dough. Terraform figures out how to make it for you. It's so powerful.
Now, you might be thinking, this sounds complicated, right? A whole new tool, a bunch of commands to learn, but here's the best part. It's not. Getting started with Terraform really just comes down to understanding one simple, elegant workflow.
It all boils down to these core commands. First, you write your code. Then, you run init just once to get your project set up. After that, it's all about the magic duo. You plan, which shows you exactly what Terraform is about to do, and then you apply, which makes it happen. And when you're all done, you destroy it to clean up. Write, plan, apply. That is the heart and soul of Terraform.
And if you remember one thing from all of this, let it be this mantra: always plan before you apply, always. Think of the plan as your safety check. It's a dry run that tells you precisely what's going to be created, changed, or deleted. If that plan looks good, then you apply. No surprises, ever.
All right, enough theory. Let's see what this actually looks like in practice. We're going to take a simple piece of code and watch it become a real, live thing out in the cloud.
So take a look at this. This is it. This is a Terraform blueprint. The language is called HCL, and it's designed to be super easy for people to read. See how clean that is? It's not complicated. It's just a declaration. We're saying, hey, I want a resource group in Azure, I want it named Demo Resource Group, and I want it in the East US region. That's it. So with that file saved, the very first thing you're going to do is pop open your terminal and run Terraform plan. The output is going to show you a little green plus sign next to this resource confirming, yep, I plan to create one new thing. It's your final chance to double check before you commit.
And once you look at that plan and say, yep, that's exactly what I want, then you run Terraform apply. Terraform will ask you to confirm, you'll type yes, and bam! It connects to your cloud account and builds that resource group exactly like you defined it in the code. Just like that, your code is now real infrastructure.
Okay, now before you get all excited and start building stuff, we need to talk about the one golden rule. Getting this wrong is by far the #1 mistake that beginners make, and it can have some pretty serious security issues. So listen up.
Here's the deal. Terraform needs a way to keep track of the stuff it's managing, and it does that using a special file called terraform.tfstate. The problem is, this state file can sometimes contain sensitive information. I'm talking passwords, private keys, stuff like that, in plain text. So here it is, the golden rule. Never, and I mean never, commit this state file to a public Git repository. You should always set up Terraform to store it somewhere safe and secure, like an Azure storage or a Terraform cloud.
And there you have it. That's a quick tour of taking your infrastructure from clicks to code with Terraform. We've seen how to escape the chaos of manual work by using a clear, digital blueprint. We know how to define our infrastructure, plan our changes safely, and apply them repeatably. So the only real question left is, now that you have the blueprint, what are you going to build first?